In this video, I'm going to be talking about number sets. But before I do, I would like to take a few steps back and talk about variables. Why? Because I know that some of my students are not as familiar with mathematics as other ones. And I want to help them out. The first thing I want to talk about is a variable. A variable? What's that? Okay. The best way to illustrate a variable is to talk about Old Hallows Eve, otherwise known as Halloween. You know, that little holiday where all the kids get dressed up in their nice little costumes and it's kind of hard to recognize them if you can recognize them at all? Okay. Same principle. The thing is that when a kid wears a costume, he does not change. His costume changes him, but he himself does not change. As soon as you take that costume off, it's still that kid. Get the picture? Alright? So just because you can't immediately recognize him doesn't mean it's not the kid. It just means you can't immediately recognize him. That's the difference. Okay? Same thing with numbers. Let's say you have the number 2. Just because you replace that number 2 with the letter X doesn't change the value of the number 2. It just means you don't immediately recognize the number 2. Same difference. So you have an equation x plus 3 equals 5. Well, of course, x being 2, well, the 2 doesn't change just because you now have an x on it. It just means that the 2 is now in disguise. And that's the same way it is with all numbers. That x could represent 3, 5 1/2, 7 7/8. It doesn't matter. Whatever number x is representing, that number doesn't change just because now x is representing it. It's still the same number. Okay. Now why do I bring this up? Because sometimes variables represent numbers and other times variables represent number sets. Now, do you remember my previous video where I was talking about the letter Z and how that represented a number set of integers? Okay, we're going to continue our discussion of integers. So everything's going to be represented in integers now instead of just regular numbers. Okay. Now, how do we know if a variable is representing a number or a number set? Well, we have something called set notation, and that's what these little squiggly lines are all about, right here. Okay? So at least one of these variables is going to be a number set rather than a number. Well, guess what? In this case, it's going to be that one right there. That represents a number set, not just a number. Okay? So, what does this great big vertical line represent? It represents the word so that. You are trying to find a number set so that B can divide A. Now what's A? A is a single number. In this case, we're going to say that A is 12. Now we're going to find every single integer that will divide 12. Okay, let me say that again. We're looking for every single integer that divides 12. Now what integers divide 12? Well, the first thing we have to say is that division sign right there is exactly the same as what you'd find in a fraction. Okay? A is your numerator, B is your denominator. That's how that works. Alright? So, what numbers will divide 12? Well, 1 will divide 12, 2 will divide 12, so will 3, so will 4, so will 6, and so will 12. So they are your number set. Now, how do you represent a number set to a kid? Well, do you remember when, well, some of you people do, some of you don't, but I remember when I was a kid, they used to have these things called plastic numbers. They still have them today, but a lot of people don't use them anymore. What you do is you buy a package of these plastic numbers. They have a little magnetic strip on the back. Okay? And what you do is you take the numbers 1 through 9 and you toss them into a bucket. You tell the kid, look, every number that is in that bucket, mind you, they're all integers, every integer that's in that bucket is a part of a number set, and the bucket represents the entire number set. So we can now say that B represents a bucket that is filled with 1, 2, 3, 4, 6, and 12. That's what B represents. A represents a single number known as 12, but B represents 1, 2, 3, 4, 6, and 12. Represents all of them. So, what we're doing, we're going to say, we have a number set. We need a number set so that this number set will be able to divide our variable A. Okay? And that's what that is saying. Now then, what happens if things go a little bit in reverse? Let's say we have a letter C, like this. Let's say that's your situation. Now we're trying to find a number set in which is a multiple of this. This is going to be a single variable. Let's say it's 12. Now we're going to find all multiples of 12. Well, in that case, you'd have 12, 24, 36, 48, 60, because this way, C is your numerator, A is your denominator, and every number in this number set is going to be able to be divided by 12. Okay? So C is 12, 24, 36, 48, 60, so on and so on and so forth. And that's how that one works. So your number set can either be the denominator or it can be the numerator. If it's the denominator, you're looking for factors. If it is the numerator, you're looking for multiples. And that's how that works. Alright. I will tell you more in a future video. Stay tuned.